Hello everyone, I wanted to show you how I produced this simple grid field of particles in Blender using geometry nodes, and how I animated it to produce a very simple effect that can be reused for multiple motion graphics in your projects. I spent a long time thinking about the easiest way to create a simple loop of small particles in Blender without using the built-in particle system. As you can see, this 250 frame animation loops perfectly once it reaches the end. This setup involves geometry nodes alongside a little bit of simple shading to create a multi-purpose displacement looping scene. Let's dive right in. So I'm going to get rid of my geometry nodes object. I'm going to leave behind the backdrop plane. This has a simple shading setup on it, which looks a little bit like this. If you'd like to copy the details, it's just a Voronoi texture with the distance plugged into the roughness, 4D with quite a low scale put on it, and that produces this effect where some of the lighting is reflected where it's not rough, and where it is rough then the lighting isn't reflected. And my world lighting is built upon an HDRI that is restricted using a color ramp combined with a volume node to give the world settings a little bit of life. So onto the main object, what we're going to do is bring in a new object into the scene. So we're going to do Shift A, Mesh, Plane. That's going to put itself on the 0 axis of the world. We're probably going to want to bring that up just a little bit so it's hovering above our existing backdrop plane. What we're then going to do is go to the geometry nodes section of our workspace. At this point we want the plane. We're going to select new to apply a new modifier to this new plane. Yes, make sure you select the right plane. So what you do here is you delete the group geometry input. We're not going to need that. We're also probably not going to need our N panel here, so push the N key to get rid of that. Okay, so the basis of this geometry nodes object is a simple grid. So you do Shift A, click at the top to search, and go for grid as part of your geometry output, and it will appear in the scene. You can also up the size of the grid. I went with 5 meters for each of the inputs, and you probably also want to bump up the number of vertices. I would say start with 50 and go from there. So if we swap ourselves to wireframe mode, we can now see that this grid has been created, and it will have 50 by 50 on the number of vertices. Right, what do we do from here? We want to distribute some points on this. So we want to, it's already got some points, we want to distribute instances on those points. So that's this node here, instance on points. Bring that one in. You'll notice your grid disappears, but suddenly we have 2.5k instances on which we can put things. What do we want to put on those things? Well, you can really put any object you like. You can bring in another object from your scene. What I did in my example was a simple icosphere, because at low resolutions it looks like a speck of dust. It's quite useful. We want the initial basis to be very small, 0.02, and 1 subdivision. If we then pop that into our instance, bam, suddenly we have uniform cubes. Sorry, uniform spheres that form the basis of our motion graphics. Now, what I did from here was a simple randomization of the scale being a simple float value. So what we can do there is random value. And this would just literally be for the scale. And as you can see, that changes things. For every single object, it will now randomize the scale from 0 to 1. You can of course bump this up or bring it lower, bring the minimum up if you want to change things like that. I kept these at default, but let's just put it at, say, 0.1 to 1.3, why not? Now, we want to, for the rotation, this is a vector, it's 3 values. What we want to be doing is Shift deduplicating our random value and changing it to a vector. Plug that into the rotation. The max being 1 is not going to work because we want rotation, so 360 degrees on all axes should suffice, and therefore every single object has a random rotation in the X, Y, and Z planes from 0 to 360 rather. So that's the basis of our pattern. But what you might notice is it's not moving up or down, it's just static. If I pushed play on a timeline at this point, go back to our layout, what you'll notice is nothing is happening. Not very interesting. We're going to change that. What we want to do is translate instances. At least this is what I did. There's probably many ways to do this particular process. Turn off local space. I use global space for this. Again, your mileage may vary. The essential basis of what we want to do, we want to plug in some vectors into these that change over time. Now, the way I've done this for my showcase has been with a noise texture. It's quite useful. So we want a noise texture that is 4-dimensional. That gives you this aspect W, which kind of acts like a seed. You can change it over time. We want to plug the factor into the translation, and suddenly everything is launched. Now, what you might notice without it and with it is it suddenly gets pushed up in the air in the Z direction. We actually don't want that at all. So what we're going to do after the translation is the set position. At least this is the way I've done it. And we can therefore bring our Z position down slightly, minus 0.5 on the Y and minus 0.5 on the X, centers everything out, because noise textures run from 0 to 1 on the translation, therefore everything is averaged to 0.5 in its translation. So that's how you would change that. So if we change the W, you may notice we get randomization occurring. Now, there are several ways to loop this noise texture to get the output desired, like in my intro. Now, one way you may have seen in the past to create a repeating loop, a seamless loop for this animation, is to manipulate this vector over time, the vector of the noise texture. The way I would tend to do this is using a combination of the vector and the W to produce a seamless loop. You also get a lot more granular control this way. So the general setup is we start with the position of each object. The system has to know the position before it can do anything. What we then want to do is add a node called scene time that's built into geometry nodes. It's a very useful node. You can therefore run your animation based on the existing frame. So when it's on frame 2, this will output 2. When it's on frame 3, this will output 3, so on and so forth. Once you get to 250, it outputs 250. So what can you do at that point? You can divide, or rather use a math node to divide this, because if you output this straight to the W, and let's just bring up if we bring up a timeline, press play, you might notice it's going very quickly. We therefore want to divide this by a certain value. What we want to divide it by is the total number of frames in our animation, which for my one is 250, as you can see down here in the bottom right. You can set this to whatever value is yours. 250 means it will get to 250 and circle back to 1. Very, very useful. Rather than adding, you want to make sure that's divide. What we then want to do is combine XYZ, because we do not want it messing around too much with our Z. What we want is shifting left and right. You can do Z as well. If you'd like to do that, go for it. It might produce slightly different results for you. So X and Y, that gets plugged into. And we want to, if we just bring this over to the left, what we want to do is vector math, add, and we want to add the initial position to whatever new position it's giving us. So it's got its initial one as it's set here in the noise texture, and it's going to add every single frame. It's going to add the frame divided by 250 on the X and Y values and pass that through to here. We probably want to scale this. So at the moment, if I just pop this straight into the vector, it's moving a lot, but not much. We can affect that by doing vector math again and simply setting this to scale. So this could be effectively how quickly this whole animation is going to move. So you can lower this to get a very smooth animation. You can raise it to get a very fast animation. Well, once it gets to 250 and bounces back to 1, there's a very large seam in our scene. It's very obvious when it reaches the end of the animation. This is where there's a little bit of tricky maths that gets involved with how this all loops together. It involves the vector that we've currently got and the W together. Again, you can affect the scale of the noise texture to make it higher in peaks or lower in peaks. Anyway, let's do the maths bit. So what we want at this point is a separate XYZ. And this gives us kind of a neat output if we just take the X. In fact, you could use this to just produce some very interesting waves on your textures or your objects, but nonetheless, we're going to detach that. How do you drive something to produce a loop? Well, in maths, there are sine and cosine functions that over the course of a cycle will loop. If you think of it as a graph, they will loop themselves over time, back and forth, back and forth, back and forth, whether they're sine or cosine. It does not matter, but what we use in this example, the way I've worked it out, the way it works for me and that I've seen some other people use, is we take a math node and we set it to sine. So it's going to take the sine of x, so we want the sine of x, and we're going to duplicate this, and we want the cosine as well, so we want the cosine of x. And then we also want the sine again for y, and the cosine again for y. So we do xx, yy, leave the z. You could do another one for z if you want z as well. I'm not going to be doing it in this example. Now, how do you combine these back into a vector? Rather than just maths, we combine xyz. However, xyz is not strictly, you can use these values to drive anything. So while we're saying move z, when we connect these up, it's actually going to take up slightly different forms when it comes out for the animation itself. Just bear that in mind. There's a little bit of tricky maths that, to be honest, I don't fully understand. So we're going to connect the sine x to x. We're going to connect the cosine x to y. Interestingly enough, we're going to connect the sine of y to z. And we're going to connect the cosine of y to w. And suddenly, if we connect the last vector up, what we end up with is a nice, pretty pattern. Once it reaches 250, it should seamlessly loop. It's not doing that. I've missed an important part. Scale here. How big your scale is will affect how fast the animation plays. You want the animation looping, and therefore we're going to have to do some vector math on this. So scale is not something that can just be plot wherever you want. Scale has to be related to the maths involved with sine and cosine. So if you think about a circle, this is the way it was explained to me, and all the way around a circle in degrees is 360, all the way around a circle in radians is 2 pi. And because we're dealing with vectors, we're dealing with radians, what we can actually do is 2 pi into here. 2 pi is also known as tau, T-A-W. So, T-A-W, put that in, suddenly your scale is right. If you want to be changing how fast your animation plays, you can therefore up the scale of your noise texture, and that will affect the animation. But if we put this very low, we end up with this lovely looping motion graphic that is rather mesmerizing. And you can use this maths here to drive any of the textures, noise textures that go round if you want them going round in a loop. That's how you would do that. Now, the shading I did for this was incredibly basic, and if you want exactly the same result, then just follow what I did. At this point, we're going to do Ctrl+S to save our project in a blend file. If you head to your shading workspace, I would advise bringing this up. Make sure you also have a camera in your scene positioned how you like. To bring a camera into your scene, you just do Shift-A, camera, position the camera how you like, 0 on the numpad to look through the camera. So, our plane object needs a material, and again, there is a very important part of geometry nodes I've missed. This is what happens when you create something on the fly. What you need is a set material node. I'm always going to forget this every single time. So let's put it here, and let's create a new material. Let's just call this grid. So then material, grid, select that in your set material. In fact, we could bring it over there, but I think this will be fine here at this point. Yeah, it's got the material on it. So, what material setup do I want to be doing? Well, the way I did it before, and again, this is very basic, I did a mix of 2 different shaders together, 50%. So I wanted kind of a glass glossy shader, just a very basic one. Pop that in the second slot, and the first slot you've just got this basic white shader, but we can change that by affecting its emission. So the way we would like to do that is another noise texture. This time leave it on 3D, and another color ramp that we've used before, but the factor into the factor, the color into the emission. And again, you'll notice at the moment nothing really happening, but that's because we need to set our colors. So for instance, what I did before was a nice blue color here, and I put another pin in the middle, and I set that one to purple, and then white I set to let me think, probably some kind of pink. Let's put it to purple. And suddenly that's the emission that you've got on your object, and you can up the emission strength to get the effect of them glowing against your background. Again, you might want to slightly differentiate some of these, get a different effect, get some pink in there perhaps, maybe a lighter blue. Bring these closer together. You can have some changes to the easing between each of the colours in your colour ramp by swapping out the interpolation. Constant means these harsh lines between each object. Linear is a bit softer. B-spline is even softer. Just play around, make something you like. In this example, I'm going to leave it on linear for now. All that's left to do at this point, probably pop back into layout mode, line up your camera, make sure that your camera settings are as you like, so go to camera, set the perspective. Eevee's much quicker. You do want to turn on bloom, ambient occlusion as well, I guess. Motion blur is pretty good, and make sure your output is as you want. If you want this on something like a YouTube video, then 1080p will be pretty good. You could bump it up to 4K if you want. Make sure to set your frame rate as well, and your start and end frames. And you probably also want to check where your output is going. The way I like to output these things is either FFmpeg video or a JPEG or a PNG, and you just want to check to make sure where you're outputting it to is going to be suitable. And then at the end of it all, once you're ready to render the entire animation as is, you just simply go to render and render animation. So this is the output you can expect at the end of this tutorial. It doesn't look quite like the one I had in my video, simply because the shader is different, but you get the idea, and I hope you can use this in your projects. If you like this video, please do give it a subscribe, it helps the channel a lot. Do check out my projects on Gumroad if you'd like the files, and I wish you all a very good day.